dear students, welcome to our channel TJ CBSE classes. Today I am discussing a topic, resistivity of the material of the wire, and the difference between resistivity and resistance. It's very important for yours. Okay, the resistivity of the material, resistivity. Of the conductor. Here the resistivity can be denoted it as rho, and the resistance of the wire can be denoted it as R. Okay, here we know that we have the resistance of the conductor R is directly proportional to length of the conductor. In the last class we studied that when length increases, resistance of the wire, conducting wire or resistance wire also increases. That means resistance of the wire is directly proportional to length of the conductor. R is directly proportional to L, and R is inversely proportional to area of cross section. The resistance of the conductor in both resistance of the conductor is directly proportional to the length and is inversely proportional to area of cross section of the wire. Okay, then we can combine these two. R proportional to L by A. Here we can combine these two, R proportional to L by A, or R is equal to rho into L by A. Here rho is proportionality constant. Here this proportionality sign can be replaced by rho and put equal sign. Then R is equal to rho into L by A. Rho is called resistivity of the material of the wire. Rho is called the resistivity of the material of the wire. Okay, here it's an important equation. R is equal to rho into L by A. It's a very important equation. If length of the wire is taken as 1 meter, area of cross section is 1 meter square, what happens? If you are taking the length of the wire is 1 meter and the area of cross section of the wire is 1 meter square, then R is equal to rho. Then how we can define resistivity? Resistivity of the material of the wire is equal to resistance of the wire. One condition is that two conditions are there. When length of the wire is 1 meter or 1 unit and the area of cross section is 1 meter square or 1 square unit. Okay, then can be defined, the resistivity of the material of the wire can be defined as the resistance of the wire. That means rho equal to R. Two conditions are there. Length is 1 meter or 1 unit, area of cross section is 1 square unit. From here, this equation can be taken as equation 1. From equation 1, rho is equal to RA by L. Okay, then take unit of resistivity. Unit of resistivity is ohm meter square by meter. Here 1 meter can be cancelled. 1 meter can be cancelled. Then unit of rho is ohm meter. Ohm meter is the unit of resistivity. Okay. Then resistivity actually it is a standard value of resistance. Resistivity. Here for resistivity, two conditions are there. Length should be 1 unit and the area of cross section is 1 square unit. Okay, at that condition, the conductor having some resistance, that resistance is known as resistivity of the material of the wire. Okay, then here this area of cross section can be taken as, for a conductor with a circular cross section, is pi r square, or else in terms of diameter we can take pi d square by 4. Pi d square by 4, both are same, because here instead of radius we can multiply and divide it with the 4. Then here it will be 2r square will be diameter square, then by 4 will be there. In terms of radius it is pi r square, and in terms of diameter it is pi d square by 4. Okay, then the resistivity, the resistance of the wire R equal to rho into L by pi R square. Okay, then take this equation, rho is equal to R A by L. Instead of A it is R pi R square by L. Or else in terms of diameter, rho equal to pi R d square by 4L. This is the equation. These are the two important equations related to resistivity. Here rho is equal to R pi R square by L. In terms of diameter, it's very important. Pi R into d square by 4L. Okay. These are the things related to resistivity of the material of the wire. Okay. Then here two important problems are there. The first problem, here for first problem, if the resistance of the wire, here this one is the resistance of the wire, having the length A and area of cross section A. Then here this resistance wire is stretched twice. After stretching, what happens? Area will be half after stretching. Up to twice the length. After stretching up to twice the length, what happens to the area? Area becomes half and the length becomes 12. Here, after the modification, there won't be any change in volume. That means volume is equal to area into length. Okay. Area is half, means length becomes twice. When length becomes twice, then area will be half. Then 2 can be cancelled. That means there is no change in volume. That is why here, when length becomes twice, then area is halved, because after stretching there is no change in its volume. Only area and length will be changed. Then what happens to the resistance? Then R is equal to rho into L by A. Here, when length increases, what happens? The resistance also increases. That means rho into, instead of L it is 12 by A by 2. Here 2 will become up numerator. Then it will be 4 into rho L by A, or 4 into R. That means here after stretching up to twice the length, the new resistance will be 4 times of the initial resistance. It's very important for related to resistivity. When a resistance wire stretched twice the length, then what happens to the resistance? Resistance becomes 4 times. Here stretching repeated once more, what happens? If the stretching repeated once more, then R2 will be 4 into 4R. If the same process repeated once more, then 16R is the new resistance. Okay, one more problem is there. The second problem, second one. If the resistance, here it's a resistance wire. It's a resistance wire, L, area is A. Then it is doubled up by folding. Doubled up by folding. Doubled up by folding means just folding. Folding, what happens to the length? Length becomes half and the area becomes 2A, because there is no change in volume. Here, if it is doubled up by folding, means area increases 2 times. Then length will be half. Then what happens to the resistance? First resistance R is equal to rho into L by A. Question 1. After doubled up by folding, what happens? the new resistance, here length changed, length and the area cross section is also changed, then resistance also changed. Here rho into the resistivity has no change. 2 L by 2 by 2A. It will becomes rho into L by 4A. That means R1 becomes 1 by 4 times of R. The new resistance will be 1 by 4 times of R. Okay, this is here the factors affecting resistance is MALT, M-A-L-T, material, area cross section, length and temperature. But in the case of resistivity, the affecting factors are only two. Then first one is temperature. When temperature increases, resistivity also increases. Then second one is material. If you are taking two different material, resistivity is also different. Okay, thank you.